On this video, we're going to be explaining worksheet 10.3 WSPM. Your assignment is to do 2 through 22 even. I will be explaining some of these, not all of these, but just some so you could get a hang of it. In order to do these problems, you need to have all this information in your head or in your notebook in front of you, right? What do we need to know? We need to know especially the a sub nth rule of a geometric sequence or series. A sub n equals a sub 1 times r to the power of n minus 1. We also need to know the summation formulas of geometric series, right? If they give you a sub 1 and a common difference r, then you use this one. If they give you your first term a sub 1 and your last term a sub n, then it would be easier to use this one. Anyhow, let's jump right into it. I will begin with number 6 as it looks easier than 2 or 4. So if you understand number 6, you should be able to do numbers 2 and 4 easily. And on number 6, the instructions say to find a sub n. They want the a sub nth rule. They want the machine that'll produce this situation where your first number is this crazy negative 78,125 and where there's a common ratio of 1/5 between the terms. And they tell you that your sequence is 9 numbers long. Okay, so again, we want the a sub nth rule. So we're not talking about the summations, we're talking about the a sub nth rule. So let's jot down that a sub nth rule. So they give us the a sub 1 term, which goes right here. They give us the r, which is 1/5, which goes right here. And they give us the n, which is 9, which goes right here. And now that I think about it, they're giving us all this information. They're not really asking for the a sub nth rule. They're asking for the a sub nth term, which would be the last number on your list, which would be that 9th number. So they want to know what number is the 9th number of the list, of the geometric list that begins with negative 78,125. So think about this. A sub 1 is this. The next number would be this number times 1/5. It'd be dividing it by 5 and you'd get a smaller negative number. And then the next number would be multiplying by 1/5 again, which would be smaller. So this list is kind of like an exponential decay function if you think about it. So by the time you get to the 9th number, it should be very small, a very small negative number, very close to 0, if you think about what this is saying. So once again, they don't really want the a sub nth rule, they want the a sub nth number, that 9th number. Here would be the a sub nth rule. You would write a sub n equals a sub 1, which is negative 78,125, times the common ratio r, which is 1/5, to the power of n minus 1. Now, this is the a sub nth rule, right here. This is the a sub nth rule. But since they actually gave us the n, saying that there's 9 numbers, I'm pretty sure that the answer key doesn't show this. They want the actual a sub nth term, which should be the 9th number. So let's actually plug in 9 and see what it gives us, okay? So in other words, that 9th number, a sub 9, is going to equal negative 78,125 times 1/5 to the power of 9 minus 1. So let me rewrite this as, instead of 9 minus 1, let's put an 8. And of course, it is calculator time. So when you go 1/5 to the 8th power, that's like putting the power of 8 on the 1, which stays 1, and the power of 8 on the 5. 5 to the 8th is 390,625. So what we really have here is negative 78,125 times 1 over 390,625, 390,625. So the question becomes, could you reduce this number over this number? And with the calculator, the answer is yes. 78,125 will go into this one 5 times. So in other words, this cancels with that. There's a 5 left over. So your final a sub nth term is negative 1/5. Okay. So again, this was a sub 9. So that 9th number on the list will be negative 1/5. Now I just paused it and I checked the answer. And the answer in the answer key, it shows it as the 9th term being negative, let me write it up here, negative 0.2. And this is the same as -1/5. If you think about -1/5 written as a decimal, if you actually type in 1 divided by 5, it'll come out as 0.2. So this is the same answer as this, don't freak out. I kind of like rather having fractions as opposed to decimals, but either way is fine, obviously. So now that you saw number 6, I'm pretty sure you guys could do numbers 2 and 4. Easy peasy, right? Okay, we are moving on to the next section, and it says we're writing the a sub nth term, so that means the a sub nth rule, the machine that actually produces these lists, right? And we are doing the even ones. So let's pick, I don't know, I guess I'll go for the hardest one, like always. Looks like number 14 is the craziest one, so let's do that. And once again, we need our notes right here, the a sub nth rule. So I'm simply going to cut it and put it here so we could use it on our number 14. All right, so we want the a sub nth rule. So we have a sub n, let's begin with that. A sub n equals a sub 1, the first number on our list. So we have negative 16,384 times the common ratio, which we don't know yet, to the power of n minus 1. Okay, so how could we find this common ratio? Again, you take a number and put it over the previous number. Okay, so take this number and put it over the previous number. It's this number divided by this number. And if you do that, if you take the negative 2,048 and divide it by the negative 4,096, you will see on a calculator that the common ratio, because this is a common ratio after all, is positive 1/2. Okay, and it doesn't matter which one you actually use. You could have used this one with this one, or this one divided by this one, and they all equal 1/2. If you, on a calculator, if you take negative 8,192 divided by negative 16,384, hit equal, the answer will be positive 0.5 or positive 1/2. Anyway, we now know that the common ratio is 1/2, so let's put that 1/2 right in there. And guess what? We're done. This is the a sub nth rule. Now, let's say you weren't too sure about this. Let's say you're taking a test and you wanted to verify that this is correct. Well, you could plug in the number 1 as your n and see if it gives you the first number. You could plug in the number 4 as your n and see if it gives you the fourth number, which it does. So this middle section is actually very, very easy. So I'm pretty sure you guys will do great on numbers 8, 10, and 12, as it's done exactly the same as number 14, the one I just did. Now for the last section. Okay, the last section we're talking about series. Now what do I mean by series? When you add them up, right? When we're talking about the summation. That's weird that there's no sigma notation right here. That's actually a horrible fact. We probably should practice some with sigma. Maybe on another assignment. Anyway, we will be using these notes over here with regards to summation, the series, right? So we have both of these formulas for the summation of geometric series. The question is, which one do we use? If they just give you a sub 1, then you use this formula, and r, of course, and you'd have to factor out that a sub 1. If they give you a sub 1 and a sub n, then you could use this formula over here. That way you don't have to factor out an a sub 1, right? Those are two different numbers. You don't have to worry about factoring. So it depends what they give you. Let's take a look at what they give us on number 21. I know you're supposed to do 22. 21 and 22 are almost identical, so I'll do 21. You'll be able to understand it, and then you could do number 22. So the question is, whenever we have these type of problems, is what do they give us? Okay, they give us an s sub n, and both of these have s sub n, so we could plug them into both. They give us an r, which is 6, which we could plug in here or here. And they give us an n, which we could plug in there or there. The question is, do they give us an a sub 1, which we definitely need for both of these? And the answer is no. Do they give us an a sub n, which we need for this one? And the answer is no. So using what they give us, which formula would be better to use? It would be this one, right? If you want to use this formula, you need a sub 1 and a sub n. They don't give you a sub 1 and they don't give you a sub n. So you can't use this formula because you have two unknowns. Okay. Now on this formula you need a sub 1, which they don't give us, but there is no a sub n right here. There's a r, which we have, and there's a n, which we have, and a r, which we have. So in other words, over here, for us to use this formula, we need a sub 1, we need a sub n, and those are two unknown values. We don't know a sub 1, we don't know a sub n. But on this one, we have everything except for a sub 1. So that's only one unknown. Okay, so when you have two unknowns, a sub 1 and a sub n, you're not going to be able to figure that out. But if there's only one unknown, a sub 1, that's the only thing that's missing, right? Because you don't need a sub n for this one. So this is the one that you're going to use. Let's actually plug it in. It says up here s sub n equals, and we already know that s sub n is that. So let's begin with 1,295 equals the fraction. And up here we have a sub 1, which we don't know. So we're going to keep it as a sub 1. And then there's a minus sign, and then a sub 1 again times r. Notice up here, times r to the n power, times r to the n power. So that's going to be times 6 to the 4th power. And it is over 1 minus r. So you're going to have a over 1 minus r, which is 6. So ladies and gentlemen, this is an equation that has the variable a sub 1, and you could solve for a sub 1. Because after all, to use this formula, you need a sub 1. To use this one, you need a sub 1 and a sub n. So right here we have an equation where we could solve for a sub 1. So let's do that. Let's do the math. This is easy. That just becomes a negative 5. So you know what? I could just put a minus 5 right there instead of 1 minus 6. And in addition to that, up here, we need to factor out that common a sub 1 term. Right? We're going to factor out what's in common. The a sub 1 here and the a sub 1 there is going to get pulled out. Let me set this up for you. Okay. So we have 1,295 equals the fraction over negative 5, right? That became negative 5. And up here, we're going to take this a sub 1 and this a sub 1, and we're going to pull it out and put it in front. Okay. So if I pull it out and put that a sub 1 out here in front, right? We factored out the a sub 1s. What would be left in here? Well, a sub 1 times what will get you back to that a sub 1? That would be a sub 1 times 1. And then, of course, we have minus 6 to the 4th. So we have minus 6 to the 4th. Because a sub 1 times negative 6 to the 4th will get us that minus a sub 1 times 6 to the 4th. We factored out the a sub 1. Nothing left, put a 1. The 6 to the 4th is left with the minus sign in between. And now this is some math that we could easily do. Use a calculator. What is 6 to the 4th power? That is 1,296. So we have 1,295 equals a sub 1 times 1 minus 1,296, all divided by negative 5. So let me do 1 minus 1,296, and that will be negative 1,295. Of course, divided by negative 5, and of course times the a sub 1 out here in the front, and it's still equal to 1,295. Okay, so I need to continue to solve. I need to get a sub 1 by itself on the right side of this equal sign. So I'm going to multiply both sides of this equation by negative 5. That way it'll cancel out. Multiply this also by negative 5. So 1,295 divided by negative 5, times negative 5 will be, that gives us negative 6,475 equals the a sub 1 times that negative 1,295. So if you get rid of that negative 1,295 by dividing by negative 1,295, that'll cancel, and we do to one side, you do to the other, which will take you back to positive 5, okay? So a sub 1 equals positive 5. There you go, we did it. Okay, so they ask us to find a sub 1 for each geometric series given the information. We took the information, we decided which formula we're going to use, and we plugged everything in and we solved for a sub 1, which was a missing value. Okay. That was 21. It's almost identical to 22. So go ahead and hit pause and try to do 22. You know what? I did say stop on 22, but you might as well try also to do 24. Okay. Or how about this? I didn't assign it. I'm going to do it, but I want you to follow along with me at the very least. On this last question, we're going to use this summation formula right here. And why are we using this one? Because they give us S sub n, they give us A sub n, they give us R, and of course on this section they want us to find A sub 1, the first term on our list. That's what the instructions say on this last part of our worksheet. So let's plug in what we have. Instead of S sub n, we have negative 342, and that is equal to a fraction, and up on top we have A sub 1. We don't know what A sub 1 is, right? We don't know that, so we just rewrite it. Minus A sub n, see A sub n up here? That's really negative 512. So we have negative 512. But then again, we have times R, and R is negative 2. R is negative 2, so we put times negative 2. And of course, this is all divided by 1 minus R, which is negative 2. So we really have 1 minus negative 2. And of course that minus minus in the denominator changes the plus plus. So what we really have here is negative 342 equals A sub 1. Now right here I have a minus minus 512 times negative 2. So before minusing or adding, because he changes the plus plus, before doing that we should multiply. So I'm going to call this a negative 512 times a negative 2, so that will be positive 1024. So this minus sign, I'm going to bring it down. That's a minus sign right there. And this negative 512 times negative 2, that becomes positive 1024. Positive 1024. Okay, so what we really have is A sub 1 minus 1024. Okay, and it is still divided by 1 plus 2, which is 3. So here's our equation. We need to solve for A sub 1. So let's get rid of this divisor of 3. How do you get rid of the division of 3? By doing the opposite of dividing by 3, which is multiplying by 3. What you do to one side, you must do to the other side. 3 times negative 342 is negative 1026. So we have negative 1026 equals A sub 1 minus 1024. So for the final part of isolating A sub 1, of solving for A sub 1, that first term on our list, we'd have to add the 1024 to get rid of it. And what you do to one side, you do to the other side, 1024. So what you really have here, guys, is a negative 6 and a positive 4. So this will be a negative 2, right? If you do this on the calculator, 1024 minus 1026, that will give you the answer negative 2 equaling A sub 1. So the first number on this list, given the information for number 24, that first answer, or that first number, is A sub 1 equals negative 2. Here are the answers to the whole worksheet. We're doing the even ones. And of course, all these answers are on PDF. We skipped that part. That's not even on your worksheet. 22 and 24. The one we just did right now, that was negative 2. All right, guys, I hope you guys understand what we're doing here.